So we're going to continue doing problems through here. Okay, so the first one we're going to look at is the police academy candidates. Okay, so first thing is, well, we'll read the problem. So to qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify and assume the scores are normally distributed. Okay, so we're going to start out just saying it's a normal distribution, okay, with a mean of 200. So I'm just going to use the notation that we've learned, and a standard deviation of 20. Okay, so now I'm going to draw the normal curve. My pen is not working properly. Okay, and we want the top 10%. Okay, if you want, you can go ahead and label the axis. It's not as important now, but just mostly we draw the curve so we know what to label. Okay, so if we want the top 10%, I have to be up here on this part up here. Okay, now, so that means I'm going to label this part 10%. Okay, so that part gets labeled 10%. Okay, now remember the table always tells us the part to the left. So what I need to actually look up in the table is this part here. So if this is 10%, how much is in this part? Well, that's the 1 minus 0.1, which is 0.9. Okay, so now if we're going to go to the table, okay, and we're looking at 0.9 in the table. Okay, if you notice, none of these, the highest I get here is this 0.4641, so I need to advance a page. And we're looking at 0.9, so I'm going to look along here. Here's 0.888, here's 0.9032. So it looks like we're in between 1.28 and 1.29. Okay, this one's actually pretty close, right? So we're just going to say it's 1.28 is the value I'm going to use. Okay, so that tells me that my Z equals 1.28. Okay, now remember we had the formula for Z, so Z equals, right, the X minus the mean divided by the standard deviation. Then I also gave you that other formula that was actually already solved for x. In that case, this is what we're trying to find. So x equals oops, let me start over. I want to make sure I give it to you the same way I gave it to you last time. So x equals your mean plus z times your standard deviation. Okay, so I'm going to use the formula in this form. So my x is 1.28. My mean is, I'm sorry, that's my z. So z times the standard deviation. My standard deviation is 20, so mean times 20. Okay, add in the mean, which is 200. Oops. And then that'll tell me what my x is. Okay. Okay, so that gives me an x of 225.6. Okay, now we can also again do this with the applet. So if I come over to StatCrunch, okay, so remember it's under stat and calculators normal. Okay, my mean is 200, standard deviation is 20. Okay, this time again we know this piece is 0.1, but we want the part that's greater than it to be 0.1. So that's the piece I want there, and there's the 225.6 that I just came up with. Okay, So again, that problem is like what I would call backwards in terms of I give you the percent, you have to find the X value. Okay, so let's try the next one about babies' birth weights. Okay, so birth weights of babies in the United States, I think that's supposed to be an S, can be modeled by a normal distribution with a mean of 7.3 pounds and a standard deviation of 1.3 pounds. Babies weighing less than 5.5 pounds are considered to be of low birth weight. Okay, so let me erase what I have here, or maybe just get a new piece of paper. Okay, and then again, we're looking for these probabilities. So what I'm going to do is we're going to draw the curve first, even though it doesn't tell me to draw the curve. Okay, so I'm going to go ahead and draw a curve. We can get labeled if we'd like. So here's with a mean of 7.3 and then 3 marks on each side. Okay, and then we're going to add and subtract the 1.3 for each of those marks. Okay, so I have my normal curve all labeled. The first one, what's the probability the baby is born having a low birth rate? Okay, so low birth rate is 5.5 pounds. Okay, so 5.5, let me use a different color. Okay, is going to be somewhere around here, and we want this piece in here. Okay, so we drew our picture, we shaded our region, so the next step is we're going to calculate our z-score. Okay, so z equals the 5.5 minus the mean, which is 7.3, and then we're going to divide that by your standard deviation, which is 1.3. Okay, use your calculator. Okay, and we get negative 1.38. You notice the z-score is negative. That's because my value is below my mean. Okay, so now we're going to go over to my table, and we're looking up negative 1.38, which is on the previous page. Okay, so negative 1.38 is 0.0838. So I'll come back over here, and I get 0.0838. Okay, so that means a little over 8% of babies are born having a low birth weight. Okay, so if I come over here and check my answer with my calculator, right? My mean is 7.3, standard deviation is 1.3, and we want less than 5.5. And get that 0.0831. Okay, slightly different again just because of the rounding. Okay, so back to my next problem. Okay, I'm going to use this same picture. What's the probability that the baby weighs more than 10 pounds? So 10 pounds is out here. Let me go back. Okay, so we're here, and we're looking at this part right in here. Okay, so again, we're going to calculate a z-score first. Okay, and then we're going to look that number up in the table. Okay, my z-score comes about to be 2.08. So we'll come over here to my table. Oops. And we're looking up 2.08 and 2.0. The last column is 9, so it's 0.9812. So 0.9812. So I come over here. 0.9812. Now remember we shaded the left side, the right side. The table always tells me the part to the left. Plus it makes sense that my answer should be fairly small. Okay, so that means that's where I have to do the 1 minus it to get the answer. So 1 minus that is 0.0188. Okay, so almost 2% of babies weigh more than 10 pounds. Okay, so if we check that on Crunch It, I just need to make this a 10 and change this to greater than, and there's my 0.0189. I had 0.0188. Okay. Okay, and then the next one is, what's the least a baby should weigh if the baby was in the top 10% of birth weights? Okay, so the answer that we just came out with here, right, is only 1%, 1%, and we want the top, top 10%. Okay, so the top 10% is probably somewhere over here. Okay, so we're looking for all that part and down. Again, it's the top 10%, so this time we're labeling this part 10%. But remember what the table tells you. The table always tells you the part to the left. We have the part to the right, so how much is to the left? Well, that's 100% minus the 10%, which gives me 90% over here. Okay, so again, if you go to your table and look up 90%, we already did this one time if you remember, okay, and look up 90%, we said, oh, there it was, 1.28. Okay, so for this part it tells me my z value is 1.28. Okay, but I need to know what x is. So we're going to use that same thing I had for x earlier. So x equals the mean, which is 7.3, plus your z-score. Remember, a z-score tells you how many standard deviations you are from the mean. So this piece is, I'm 1.28 standard deviations from the mean. So that's why you end up multiplying these two numbers together. Okay, and then adding it to the mean. Okay, so then use your calculator. Okay, and that gives me 8.964 pounds, or about 9 pounds. So a baby that weighs 9 pounds or more would be in the top 10% of birth weights. Okay, and then the last one is you want to be in the bottom 10% of birth weights. Okay, if you remember, this green line here I drew actually ended up being the bottom about 8%. Okay, so if we want to be in the bottom 10%, we'd actually weigh just a little bit more than 5.5 pounds. Okay, so you're going to be here. Again, this time we can actually look up the 10% because that's the piece to the left. Okay, so if I come over to my table, I'll do the last two problems on the applet here in a second. I'm looking up 10%. Remember, 10% is 0.1. Some mistakes that are made, sometimes people start looking up 0.01. Okay, so 0.1 is somewhere in here, and if you say, oh, that one's very close, so negative 1.28. Remember, the table's all symmetric, so if the top 10% is at positive 1.28, the bottom 10% has to be at negative 1.28. Okay, and again, we're going to use that same formula. Okay, so here's my z-score of negative 1.28. I plug in x equals the mean plus the z times the standard deviation, which gives me 5.636 pounds, which agrees with what we said to start with. It's just going to be a little bit larger than the 5.5 pounds. Okay, so if the baby weighs less than 5.6 pounds, they're going to be in the bottom 10% of birth weights. Okay, so if we come over and do these last two over here in my applet, okay, remember this time I know this number, we're going to fill in 0.1 there. The first one is in the top 10%, so we'd want this to say greater than. So press compute, right? And there's your 8.96. Okay, if I change this to less than, again, I'm going to make this 0.1, hit compute. There's your 5.63 pounds that we had. Okay, so again, either way you want to do this will work, or have a link to a different applet if you want it in case you can't get in or have problems accessing this one, so you'd still have a chance to actually do the homework using an applet if you want. It'll be posted in the Chapter 6 module.